Lines and angles, this is also covered under the topic of angle chasing, is basically applying some properties of triangle, that angle sum property, exterior angle property, and other properties of circles, parallel lines, to find out missing angles and solve problems. This is an important topic starting from intermediate Olympiads to International Mathematics Olympiad, and in between all the other stages, national Olympiads, regional, every Olympiads. This is an essential topic. We will restrict ourselves to intermediate level, and we will solve a easy problem from IMO also. As well, the most important thing, parallel lines. First of all, straight lines. If we are given 3 points, one point is A, another point B, another point C, and we draw some angle, such that this and this is angle alpha and this is angle beta. Alpha plus beta equals to 180 degrees. Then only we will say that ABC is a straight line. ABC is a straight line. Only then only it will be a straight line. Now what about parallel lines? If we are having two lines parallel to each other, which have been cut by a transversal, then this angle, if this angle is theta, this angle is also theta and are known as corresponding angle. These two angles are vertically opposite angles which are also equal. This angle and this angle are alternate angles. Similarly, this is also theta. This angle and this angle are also alternate angles. Now comes the corresponding angles. This alpha and theta, these two are called supplementary angle, and here in all the cases alpha and theta are supplementary angle, because when two angles sums up to 180 degree, they are called supplementary. So this is alpha. Let us denote alpha with the blue color. Alpha, alpha, alpha. This is also alpha. This is also alpha. alpha plus theta equals to 180 degree, or pi. Pi is nothing else, 1 pi, this unit is called radian, means 180 degree. And when two angles sums up to 90 degrees, or pi by 2, when two angles alpha plus beta sums up to 90 degree or 90 degree, they are called complementary angles. This was all about parallel lines. Now the most interesting thing is triangle. This is a triangle ABC. The sum of the interior angles, that is this angle, and this angle, 1, 2, 3, angle 1 plus angle 2 plus angle 3 is 180 degrees, and this is called angle sum property of a triangle. Angle sum property of a triangle. Angle sum property, ASP. Now what is the proof of this? Very simple thing. If we draw a line parallel to BC, then since this is a line parallel to BC, this angle will be equal to angle 3 and this angle will be equal to angle 2. These are alternate angle, and since this is a straight line, the sum of the angles will be 180 degree. Angle 1 plus angle 2 plus angle 3 is 180. Hence proved. This was the first thing. The next thing is exterior angle property. If this is a triangle, this angle is some beta. This is theta 1, this is theta 2. This beta equals to theta 1 plus theta 2. And this is called exterior angle property. It's a very useful property. Lot of problems are solved using this property. What is the proof? Very simple thing. Beta is nothing else but 180 minus alpha, if this is alpha. And using angle sum property, alpha can be written as 180 minus theta 1 plus theta 2. Simplifying, we get theta 1 plus theta 2. Angle sum property. Now another interesting thing for triangle. that angles in a equilateral triangle and angles in isosceles triangle. If this is a equilateral triangle, then all the angles are 60 degree, 60 degree, 60 degree, and all the sides are also equal. And if this is an isosceles triangle, say this side and this side are equal, then this angle and this angle are also equal. That is, angles opposite to equal sides are equal. Interesting thing is that angle opposite to largest side is larger. That is, in this figure, AC greater than AB, then angle ABC is greater than angle ACB. Angle opposite to largest side is larger. This is all about triangle. Triangle inequality. According to triangle inequality, A, B, C. The general notation says that the side opposite to the angle is denoted by the small letter. This is opposite to angle A, so this side BC is denoted by A. So this will be denoted by B, this will be denoted by C. This is general notation. Now this may be followed, may not be followed. If we are given that the sides A, B, C of a triangle, then we have to understand that the general notation is followed. In a question, if we are given something like that, the sides A, B, C of a triangle, and if nothing is given, then we have to understand. And if in a different order is given, then we have to understand according to the question. A, B, C. According to triangle inequality, sum of two side of a triangle is always greater than the third side. That is, A plus B always greater than C, C plus B always greater than A, C plus A always greater than B. If this is equal, if A plus B equals to C, this means that this is a straight line. This means that this is a straight line. Now comes polygon. We are interested with the polygons, angles of a polygon. Here another important thing, that what about the exterior angle? In case of a triangle, what about the sum of exterior angle? Sum of exterior angles. Sum of exterior angle for any polygon can be for a triangle, quadrilateral, pentagon, any polygon is always 360 degrees. Which angles are the exterior angle? This angle, and this angle are the exterior angle. This angle, and this angle are the exterior angles. Now comes angle in a polygon. What is the sum of interior angle in a quadrilateral? It is 360 degree. How this can be proved? We can just join 2 points and visualize a quadrilateral as 2 triangles and prove it. Now what happens in a pentagon? A pentagon can be visualized as 3 triangles, 1, 2, 3. So the sum of angles is 3 into 180, 540. So polygon having n sides, this is having n equals to 4, n equals to 5. The sum of interior angle is n minus 2 into 180 degree. This is sum of interior angles. Now comes circle. Circle, this is not required because separately we are going to discuss this circle. But we are going to solve a very beautiful problem from angle chasing and definitely from the concept of circle itself, which was asked in IMO. So each and every theory is important. Chord subtends equal angle on the segment. Equal chord subtends equal angle. This is one point. Equal chord subtends equal angles. What do you mean by subtends equal angle? This is a chord, say AB. At any point on the circle, it is subtending an angle, say alpha. Then on another chord, say BC, it's also subtending an angle on the same segment, same side. The side should be same. If we consider this side, then the angle will not be equal, they will be supplementary rather. But if this chord is also having length equal, CD, chord CD, then this angle is also going to be alpha. And if we consider in the opposite side, this is beta, such that alpha plus beta equals to 180 degree, that is their supplementary. Equal chord subtends equal angle. A chord subtends equal angle on the same segment, that is this is a chord AB. This is subtending an angle alpha here and angle beta here. Then alpha equals to beta. And suppose this is theta, alpha plus theta equals to 180 degrees. They are supplementary. So what happens in a cyclic quadrilateral? In a cyclic quadrilateral, the opposite angles are supplementary. This is alpha, this is beta. Alpha plus beta is equals to pi. Now if we just opposite angles are supplementary in a cyclic quadrilateral. If we extend this side, then this will be the exterior angle, say theta. Exterior angle of a cyclic quadrilateral is equal to interior opposite angle, that is theta, equals to beta. Interior opposite angle. Exterior angle is equal to interior opposite angle. Another thing is about tangent. What is tangent? A tangent is a line touching the circle at only one point. If this is the center of the triangle, circle, tangent is a point touching the circle at only one point. If this is the center of the circle, then the line or the radius drawn from the circle is perpendicular to the tangent. At that point of contact. Another important thing, most important thing is the angle made by a chord. This is a chord of a circle AB. This is a tangent. Angle made by the chord with the tangent at that point is equal to the angle described by the chord or inscribed by the chord, whatever, on the alternate segment. That is, this is also alpha, and this is called alternate segment theorem. This is called alternate segment theorem. Everything is clear. Here comes the easiest thing, reflection. A question was asked in West Bengal, I guess in the year 2016. You'd get this question in the chapter circles. This will be solved, I guess. I think this was the one and only question. In IOQM 20 also one question might have been asked. I didn't know. If a ray of light is falling on the mirror, then it is definitely reflected back. Now, according to law of reflection, if we draw a perpendicular from this point of incidence of the ray, then we have some mathematical observation that this is the perpendicular to that point of contact. Point of contact. I am not saying to the mirror, I am saying the point of contact. Then this angle and this angle are equal, and this angle of incidence is equal to angle of reflection, which is called law of reflection. Now, what will happen if a ray of light strikes on a circle? Law of reflection is also valid for this case. Here, at that point of contact of this ray, or this is called the point of incidence, where the ray of light is falling, we need to draw a tangent to a circle. From this tangent, draw a normal. And now all the laws are applicable. This is theta, this is theta, this is r, this is I. This is the concept of reflection. The first question. In the given question, there are some data which haven't been written. The data is AB equals to AC, BC equals to BD equals to DE, BC equals to BD equals to DE, FD parallel to PC. We need to find the value of theta. Try this. Solve this. Since this line and this line, this line and this line are equal, this angle will also be theta. Now since FD parallel to BC, this is also going to be theta. This is equals to this. That means this is also going to be theta only. After this point, how to apply? This is 180 minus 2 theta by angle sum property. Two angles are theta theta. Then theta theta pi minus 2 theta. Sorry. If this angle is theta, this will be pi minus 2 theta. Now this is parallel to this, means this will be also pi minus 2 theta. That earlier consideration of parallel lines was wrong. Since AB equals to AC, this total angle is also what? Theta only. Total angle is also theta. And what about this part? Theta minus pi plus 2 theta implies that 3 theta minus pi. This part is 3 theta minus pi. Then this part is also 3 theta minus pi. Now what about angle A? Angle A is simply pi minus theta minus theta. This stands for angle B, this stands for angle C. So you got a very good relation between all. This angle A is also pi minus 2 theta. Which means that by exterior angle property, angle DEB angle A plus 15 degrees. Angle DEB is simply 3 theta minus pi. Pi minus 2 theta plus 15, which means that 5 theta equals to 360, 2 pi plus 15, theta equals to 75 degrees. Theta equals to 75 degrees. Very simple angle chaser. Another question, also a simple angle chaser. What we need is simply the diagram and very simple law of reflection, that too about the plane mirror only. We do not need to consider the circle. Let's solve this problem. So this is the figure inclined to each other. Now since this is parallel to the first mirror and this is parallel to the second mirror, we can say that this is a parallelogram, AQOR. AQOR is a parallelogram, which implies that angle RAQ is theta. So this is theta, this is theta. Now since these are parallel, these and these are corresponding angle, this angle will be 90 minus theta, this will also be 90 minus theta, this will be theta. Now what about this angle? Since this line is parallel to this line, is it given or not? PQ falls parallel are inclined to each other such that a ray of light incident on the mirror M1 parallel to the mirror M2, ray of light incident on the mirror M1 which is parallel to the mirror M2 is reflected from the mirror M2, parallel to M1. So since these are parallel and this angle is theta, this angle is also theta, and since this angle is theta, this angle will be also theta. This will also be theta because this is theta and these are corresponding angle, so this will also be theta. So in triangle ORQ all the angles are theta, which implies this 3 theta equals to 180 degree, theta equals to 60 degree. That is ORQ is equilateral, theta is 60 degree, which is our correct answer. A very simple angle chaser. Another simple angle chaser. What is given in the problem? That this line equals to 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 this line. This is the given criteria. That all of these are equal in length. This angle is 80 degrees. This is x. We need to find out the value of x. So let's solve it. This is a very common problem. If this angle is theta, since this line and this line are equal, this angle is going to be theta. Applying extended angle property over this triangle, we will get this angle also to be theta plus theta, that is 2 theta. So this will be 2 theta. Now this line and this line are equal to each other. So this is also going to be theta. Similarly, this part will be now 2 theta plus theta, 3 theta. This is 3 theta. Then this part is 4 theta. 4 theta. This is 5 theta. This is also 5 theta. Now this is a straight line, which implies that 5 theta plus 80 equals to 180 degree, or theta equals to 20 degrees. Now as theta equals to 20 degree, x is what? Simply theta plus 5 theta equals to 6 theta by extended angle property. That is 120 degree, which is our answer. What is given in this question? That this is a regular pentagon and this is an equilateral triangle. That means this side, this side, this side, this side, this side, this side and this side are equal in length. We need to find out the value of x. Very easy going question. Only thing is 1, 2, 3, 4, 5. Yes. What is the sum of angle in a pentagon? We know the formula. N minus 2 into 180 degree, which will give us 540 degree, putting n equals to 2, n equals to 5, since this is a pentagon. Now this is a regular pentagon. Simply dividing it by 5 will give us the measure of each interior angle. This is the measure of each interior angle. This angle is 108 degree. This angle is also 108 degree. Similarly, this angle is also 180 degree, and this is an equilateral triangle, so this angle is 60 degree. 60 plus 108, if we add them up, we will get 168 degree plus 2x equals to 180 degree, which is the angle sum property of a triangle, which gives us 180 minus 168 by 2. This is 270 12. 6 degree is the correct answer. Try this question. We need to find the measure of this angle A, angle B, angle C, angle D, angle E. That is this angle, this angle, this angle, this angle, and this angle. One hint for this question is consider this x, consider this y, and try to find out the value of x plus y. X and y separately. I hope the question is finished. By exterior angle property, x can be written as angle C plus angle E, and y can be written as angle B plus angle D. So a plus b plus c plus d is what? Simply a plus x plus y, which is equals to 180 degree by angle sum property, which is our answer. The easy angle chaser. This 1, 2, 3, all of these are easy angle chaser. Even this was also a very easy angle chasing problem. This was comparatively a tougher one. Here comes some other easy problems. 1, 2, two easy problems are given. ABC and ABD are isosceles triangle such that ADB is 50 degree. Try this. AB equals to AC, BD perpendicular to AC. There is one typo in this question. This will be AC, BD perpendicular to AC. Now try this. I am providing you the figure. ABC and ABD are isosceles triangle. All these sides are equal. Given this is perpendicular, such that angle ADB is equals to 50 degree. This is 50 degree. It's a very easy question. To find angle DBC, let's solve this. Since this is 50 degree, this is going to be, this is 90 degree. 50 minus 90, 40 degrees. Now this is an isosceles triangle also. This total angle is what? 50 degree. So this part is 10 degrees. Applying angle sum property, this will be 80 degree. Now since this angle is 10, if we consider this as theta, this will also be theta. 2 theta plus 10 equals to 180 degree, or theta equals to 180, 70, 85 degrees. This is 85 degree. And this blue angle is 80 degree. total is 85 degree. So this part is 5 degree, which is the required angle DBC. Answer is 5 degree. Another one. We have been given BAD and also AE equals to AD. Need to find out the value of angle CDE. AB equals to AC. Angle CDE. Since these are equal, this and this will be theta. This will be alpha. This will be alpha. Applying exterior angle property, if this is beta, then beta can be written as alpha can be written as beta plus theta, that is beta equals to alpha minus theta. So this angle is simply alpha minus theta. Now we can relate alpha and theta again by exterior angle property. How? Let's see. That alpha minus theta plus alpha equals to theta plus 40 degrees, 2 alpha minus theta equals to 40 degrees, or alpha minus theta into 2 equals to 40 degrees. Alpha minus theta equals to 40 by 2, 20 degrees. And what is alpha minus theta? This angle. So this is 20 degree. Very simple. Now we are going for a difficult angle chaser. Was asked in Moscow. At least spend 10 minutes on this question. Minimum 10 minutes on this question is a very good problem. In ABC, AC equals to BC, angle C is 20 degree, M is on the side AC and N is on the side BC, such that angle BN is 50 degree, angle AMB is 60 degree. Find angle NMB in degrees. The diagram I can give you. This is 20 degrees. Now let's start to chase the angle. $50 degrees. This part is 60 degrees. What about angle A? Angle A equals to angle B, which implies that angle A equals to 180 minus 20. Is it like that? By 2. Simply speaking, 80 degree equals to angle B. Very simple part. So this part is 30 degree. This is 20 degree. Now let's go for a simple construction that construct BD such that this angle is 20 degree. Construct BD such that this angle is 20 degree and join them. what we are getting, since the total angle is 80 degree here, so this part is 60 degrees. Now this angle is 20 degree, this is 80 degree, this is also 80 degree. This implies that these two sides are equal in length. This is the isosceles triangle. BD equals to AB. Another observation you can write, BD equals to AB. Another very interesting observation, that what about this angle? Since this angle is 50 degree, just see, this is what, 50 degree, this total angle 80 degree, 50 plus 80 130, this is 180 minus 130 equals to 50 degrees. So this angle is also 50 degree, that means that this is an isosceles triangle. Write down this is 50 degree, which implies that BN equals to AB and AB equals to, just here we have written BD. And this total angle is what? 60 degree. So this is an equilateral triangle. This angle is 60 degree. This total angle is what? 60 degree. This angle, then this is what? 120 degree. This angle is 20 degrees, this is 120 degree, so this angle is going to be 40 degree. 20 plus 120, 140, 180 minus 140 is 40 degrees. Now which angle do we need to find? NMB. NMB. Interestingly, this angle is 20, this angle is 20, total is 80. So this middlemost angle is what? 40 degrees. 80 minus 20 minus 20, 40 degrees. And here the total angle is what? 40 plus 60. This part is 40, this part is 60. 100 degrees. So 40 for 140. This angle is also 40 degrees. This red part is 40 degree, and this angle is also 40 degree. This angle is 40 degree by angle sum property or exterior angle property. How exterior angle property? Since this angle is 20 degree, this angle is 20 degree. 20 plus 20 is 40 degrees. So this is an isosceles triangle, which implies that BD equals to DM. BD equals to DM. Now BD equals to AB. This implies that DM equals to AB. From this two, DM equals to AB. We do not need this also. Now DM equals to AB, and AB is what? AB equals to BN from this equation. Equals to BN DN BD. This triangle BDN is equilateral one. So AB BD BN means what? Since triangle BDN is equilateral, this DM equals to AB equals to this equals to this equals to this. Yes, DM equals to DN. Now the most important thing we got from this idea of equilateral triangle is DM equals to DN. DM equals to DN. And angle MDN equals to 40 degree. Which implies that angle DMN, we can find out, this will be isosceles triangle. DMN equals to angle DNM. And angle DMN equals to 180 minus 40 by 2 equals to 70 degree. We got the most crucial figure for finding NMB. What we got? We got this angle equals to 70 degree. This is what? Already we have written that this is 40 degree. Simply subtract 70 from 40. We'll get this angle as 30 degree. So this is how we are chasing the angles. If you are not understanding this solution, because so many different angles has been written here, you can go through this solution. The solution has been provided. The last problem from 1985 IMO. What is the inspiration behind this problem? Is this page circles? Only two this important thing, this and this, we are going to use. Similarly, I would say that at least spend 10 minutes for this question. You can even spend preferably 30 minutes. Since this is a IMO problem, circle has center on the side AB of the cyclic quadrilateral ABCD. The other three sides are tangent to the circle. If we have drawn the diagram, the first hint is diagram, that we need a diagram. Not the proper one, but at least a single diagram. The next will be, there are different methods to solve a IMO problem. 4, 5, 6 methods. We'll go for a single method only. Draw circumcircle of DCO. This is the only hint we need to solve the problem. So let's move ahead. This is AB. O is the center lying here. This is also tangent. This is tangent. This is tangent. This is the circumcircle of DCO. Touching the line AB at P. Circumcircle of triangle DCO touches AB at P. Not touches, intersects. Intersect AB at P. The first thing that we can prove is AP equals to DP. We need to prove this. That is, triangle ADP is isosceles. Let us join this. We'll enhance our imagination. APDP, AP equals to AD. Clearly visible, CDPO is cyclic quadrilateral. Cyclic quadrilateral. And we have learned that exterior angle in a cyclic quadrilateral is equal to the interior opposite angle, which means that this angle theta is equals to this angle theta, interior opposite angle. Now C is an external point and CDN CB are its tangents. Therefore, angle DCO equals to angle PCO. Since this is a tangent, that much knowledge is a prerequisite. This will be theta. If we are having a circle and an external point P, subtends to tangent like this, then this is perpendicular, this is perpendicular. If we join this, then we have right angle hypotenuse on one side. So by RHS they are congruent. This is theta, this is also theta, and the length of the tangents are also equal. RHS, this is the hypotenuse. Hypotenuse, right angle we are having, and this is the side, which is the radius of the circle. So RHS criteria is fulfilled. That is where we are getting theta here, theta here. So this angle is theta. Now ABCD is a cyclic quadrilateral given in the question, which implies that angle A equals to pi minus 2 theta. Which is enough to find out angle ADP. Applying angle sum property, we can find out angle ADP is also equals to theta, which is enough to show that triangle ADP is isosceles triangle and AD equals to AP. Now we have proved that AD equals to AP, and we need to prove AD plus BC equals to AB, which implies that now we need to prove BP equals to BC. This statement. How to prove this statement? Very simple. This is a circle. CO is a chord. P is any point on the circle. Angles subtended by the chord, same chord, are equal. This is theta, this is theta. Similarly, D is a tangent. So this will also be theta. This will be pi minus 2 theta. So this angle is going to be theta, which implies that BC equals to BP. Let me write a simple statement. Here the fundamental is angle subtended by chord CP, angle subtended by chord CO. Let me just re-explain this. Angles subtended by a chord on the same segment are equal, which means that this angle and this angle will be equal, theta theta. Now D is an external point to the circle. Let me name this circle as omega, omega. And from D we have tangents DC and DA, and from tangents we have learned that angles are equal, made to the center of the circle, made with the center of the circle. Tangents are inclined equally, made with the center of the circle. So this is theta, this is theta. Now since this is a cyclic quadrilateral, this angle D plus angle B is going to be pi. So angle B is simply pi minus angle D, and angle D is what? 2 theta. That is pi minus 2 theta. Now what will be angle BCP? Angle BCP, that is this angle, pi minus theta minus pi plus 2 theta, which is theta only. So this is also theta, this is also theta, means that this is an isosceles triangle. BP equals to CP is proved. Angle BPC equals to angle BCP, which implies that BP equals to CP. Now adding AP plus BP with AD plus BC, we have AB equals to AD plus BC, hence proved. So we are over with the questions. This was an IMO question, unbelievable.